Alright, welcome to Oxtools. For those of you who don't know me, I'm Tom. The machinery gods smiled on us again. This is a recent acquisition off of Craigslist. It's a three-phase closing power feed drill press. It's got variable speed. I think it's a 20-inch cable. I'm not positive here. Yeah, 20-inch cable with a lift mechanism. Three-phase. It's got an old Chalmers motor on it, which is kind of interesting. And then it's got this fail. Alright, something else to fix. But it's got this little XY cable on it too, which I'm going to take off now because I want to do some cleaning on it and kind of survey the whole thing. The little power feed belt on this opposite side here needs a little help. It's kind of crispy looking, so we're going to replace that and do a general clean and get it wired up and give it a go. See what happens. Put this thing off. I ended up with some of these tilting mill clamps, which are kind of nice. You don't need the heel block underneath them, so they're kind of nice that way. So. This machine has a different smell to it. And, it's related to the types of cutting oil that they use in different shops. So that's one of the first things I always notice about a new machine is what it smells like, and it's really related to the things they've been cutting and the types of cutting oils. Now some bozo welded this handle on here because they couldn't figure out how to keep a wrench on the damn thing, so that'll get changed around a little bit. Actually, you know what? I'm gonna go ahead and take this little ice off here too. And with a lot of machines, nobody bothers to clean anything, and so they end up like this. And you gotta spend a bunch of time to clean it. I don't know about you guys, but I was always taught to leave the machine better than you found it, and it's kind of a general rule. And that way, the machine's always in decent shape. What's it take to wipe it down for? It takes a minute to clean it, right? And nobody can be bothered. So. Enough that goes. Nice. Ooh, it's good sulfur cutting oil. Smells like the same stuff that they use for thread and pipe and stuff. Yeah, there goes that. Yeah, this is. This is how you tell how hammered a drill press is. You look at the table. You look at the table, and you know the thing pivots in an arc. And if you see what I call the smiley face, it's got this curve that looks like a grinning, a shit-eating grin on the table, then you know the thing's seen some abuse. This has got a few little divots in it. Not bad though. Looks like they might have put that thing on there fairly early. Well, I don't know, that thing didn't look that old. So, with an Alice Chalmers motor, and just looking at the thing, the fonts on the nameplates and stuff like that, I'm guessing 60s or something like that on this thing. Not positive though. It's got a serial number, so I'll probably see if I can look it up and see how old it is. Just out of curiosity. I may just buy the belt from Closing, I don't know. We'll see though. Yeah, it's got a good film on it here. And I'm just using a scraper here to kind of knock some of the big glop off. Yeah. Well, you guys don't want to watch hours of cleaning, I'm sure. So anyway, so we'll be working on this. I'll probably shoot a few videos of it. It's all here, and I wasn't able to plug it in and test it when I went down to get it. But looking at it, it looks fine. I don't expect any big mechanical or electrical problems with it. This is all clean inside here. Motor looks okay. Nothing weeping out of it or anything kooky like that. All the variable speed belts seem to be fine. This is free. So in general, it looks pretty good. So we'll get it fired up and drill some holes with it. Okay, so we're doing a little work on the Closing drill press here, and I got it off of the pallet jack and down on the floor and started doing some cleaning. Kind of a meet and greet, get to know it a little bit, find out all its problems and secrets. So I started poking around here in the variable speed drive, and you can see I've taken it apart part way. I needed to replace some belts. There were some belts that were in pretty bad shape. So there was, this is the one I was going after here. This is a little poly multi V-groove belt, and this goes from underneath this pulley over here, and then this is the power feed here for the spindle. So you can disengage and engage it with the quill levers, kind of like a radial drill, and it's driven off of the main spindle. It's just this lightweight belt. But this thing is a crispy critter here. It's no good. Although it's intact, so I should be able to match it up pretty easily with at the bearing house, in a local bearing house here, get a new one. The other one, while I was in there, I noticed that there was a misalignment between this pulley here and I'll show you this in a second here. This center, it has an idler bearing, and then it has the other side of the movable variable speed pulley. So there's a variable speed pulley that goes from here to here, and then small V-belts that go on the lower part to this right here. So it's kind of a two-step reduction. This will run down to 150 RPM, so it can go pretty slow. But I noticed that there was a misalignment between this pulley and the pulley that's on this shaft, and the belts were crap too. You can see here, those are, I mean, they probably work for a little while, but you know, while I'm in here getting to know the machine, I might as well replace them. They are marked Closing, which is kind of interesting, but these are standard A cross-section V-belts here that should be pretty easy to match up from McMaster or the bearing house or whoever. So I need 3 of those, and then one of these. The variable speed belt's in pretty good shape. I think I'm just going to run with that for a little while, and it's also the easiest one to change too. So let me get down here, and then we'll go over on the table and I'll show you the lower half to this bearing assembly here. And we're going to make a little spacer and fabricate a little spacer for that. So. Okay, so here's the this idler assembly, and this goes down into that hole that we were looking at up on top over there, and then here's the other the V-groove pulleys here. But you can see this thing wants to move here, and when I was poking around in there, I noticed it has a set screw in here. I don't know if you can see that right in there, a little set screw. Well, it's supposed to have two. It was missing one. So this thing had slid down. They must align those two pulleys at the factory, then lock the set screws down, and then put it in. And I guess they, it probably works fine if you have two set screws in it, and then it doesn't slide down. And that way they can build some tolerance into the assembly, so due to manufacturing stack-ups they can adjust it and get it right without having to make a million different spacers or cut something down so that it aligns. So what we're going to do is we're going to take this apart, and I measured it when I was in there, and it's about a 3/16 spacer that we're going to put in there, and that'll ride on the inner race of this bearing here, and it'll hold this pulley up so that the set screws don't have to hold it axially on the shaft. So we'll get this pulley off of here. This key feels like it's pressed in, and we'll get that off, and then make us a spacer and put that in. All right, so let's get this in our copper jawed vise here, and then what I want to do is just pluck that key out of there. I have no idea how tight it is. Let's just give it a little. Oh boy, yeah, it feels pretty tight, and that would actually make sense that it's tight. They don't want it falling down. Yeah, I don't want to monkey it up too bad. Okay, so sometimes what I do here is I grab it with the diagonal cutters that bite on the edge of the key a little bit, and allow me to kind of lever it out, and that worked good. And you see here, they've actually they put a roll pin in there so that it won't fall down. So we'll be sure to put that back in properly when we put it back. So actually I kind of lucked out there because I pulled it out at an angle, and it had enough clearance that it didn't snap that little guy off. So sometimes you get lucky, right? Okay, so that should come right off now. Yep, there she goes. Okay, and there's another little key down here. And you can see the set screw was bearing against that one there. And then nothing else. So we'll clean that up, and we'll make a spacer that's about that diameter right there, the inner race of that bearing. So see how this looks here. Oh, it looks pretty good there. I don't see any problems there. So yeah, that's what our spacer is going to look like, just like that. Okay, so here's, I decided to double check that dimension. I just kind of did a quickie measurement on it before. So you can see that this is the area that I need the spacer right here. So what I need is I need a kind of a reference to align the two pulleys. So what I did was I just clamped a 6-inch parallel on here and aligned the two bottom edges of the pulley. And I just have a little plastic wedge in here kind of holding the world up there while I take a measurement. So now the trick here is, what can I fish in there to measure that? It's kind of a tough spot to reach in there to get some kind of measurements. So yeah, I'm gonna go look at my toolbox and see what I have that I can that I might be able to stick in there and measure that reasonably accurately. I don't need to be within a thousandth or anything like that, but you know, I don't want to have to take it apart 5 times until I get it right. So, all right. So what I brought over was one of these little guys here. These are these little tiny sections of ruler, and I thought I could get that in there, but it's still too big. So I couldn't get that in there. So what to do, right? So sometimes what you got to do is you have to take an indirect measurement of something like this. So what we're going to do here is we'll slide this off, get that out of the way, and then what I'm going to do is I'm going to put something of known thickness here, and this just happens to be a couple little pieces of these are just little chunks of tool bit here, and they're 3/16 thick. So we'll slide that on now, and then what we'll do is we'll measure the difference. Well, let's see what we got there. You know, that's pretty stinking close. Look at that. Now it won't pass through there. It won't pass through there, but it's right there. It's really close. So those are 187. So I'm just going to add, so that's 190. I'm going to add 10,000. I'm going to make the spacer 200 thousandths thick, and then stick it in there and see what it looks like. It looks like, get my magnifier on here. Yeah, I'm thinking 10,000, something like that. Probably be fine. And you know, we're not, like I said before, we're not trying to get this within a thousandth or something like that. It doesn't need to be that close. It just needs to run smoothly. It wants to be in good alignment. So anyway, let's go make a spacer. All right, so we're gonna get this key out of here too. Okay, that one came out easy. So that's a little Woodruff key there. And it's a little beat up on the ends. Not too bad. Then we'll clean that up a little bit and it'll go back in fine. All right. Okay, so it's metric bearing 985, 986, something like that, and then the OD of our spacer is going to be, I don't know, 1.3. Should I measure that other thing? It's got a ring here. All right, so 1.372, so I'll make it 1 3/8, something like that. Where's that land here? That's bigger than that race, but that's okay. So 1 3/8 by 986 or something through the ID. We'll find a piece of material and make a little spacer, 200 thousandths thick. All right, so I found a piece of material, and this is when it pays to be a scrounge. You know, I can't resist a little piece of heavy wall tubing, and look at that. So it just slides right on there. It's not a super tight fit, but for what we're doing here. So this is 997. So it's about 10 thousandths clearance, which is fine for what we're doing here. And then the OD is 1.5 inches. It looks like it's just some seamless tubing, DOM tubing that's drawn over mandrel for people that haven't heard that before. So yeah, I'm halfway there, 3/4 of the way there. So we're just going to turn the OD a little bit and part a hunk off and deburr it and call her good. So. Now you see how those chips are forming? That's not that great, so I'm gonna increase the feed rate a little bit. Let's try that. It's a little better. All right, calipers. Okay, about 10 thousandths left. Alright, so here, what I'm going to do here is just, I'm going to cut it a little bit long because I want to face the other side so it's nice and parallel. Okay. We got our spacer, and I'll get a quick measurement on it. Hotter than crap. 0.21. So we need to take about 10 thousandths off of that, which is great. So what I'm going to do there, pop that in there, and then what we can do is let's see, what do I have back there? Well, just adjust this out a little bit. That's what it's for. So I can just face that off just right. Alright, so I'm just going to adjust this real quick. So 960. $970, 1 inch 970. So I want to increase it 100 thousandths, so 1,070. Okay. And these are just spacing this off of the back of the vise, or excuse me, the chuck. And the adjustability is nice because you can, quickly do an odd spacer like this and have it be parallel. Unfortunately, there's a lot of bolts to monkey with. Okay, that should do it. Okay. And looks like I need to go a little more. Well, maybe not. Yeah. I can't get it. I won't be able to get a chamfer on that to deburr it. So I'm going to run it out a little bit more. You can see it doesn't take too long to adjust it. So 70. How about 90? Sure, why not? 90. And even with, these are 3/8/16 screws here, I got pretty good resolution. I can easily adjust these within a thou and then lock them down if I'm careful. But for this thing, I'm not stressing out about it here. Okay, there we go. So now I'm just going to push that up against there. Tighten that up a little bit, and off we go. I think I'm going to do the facing with this guy here. Let's see if I can get up a little better camera angle there. What does that look like? All right, well, okay, let's go for that. Let's try that. All right, so I'm just going to come up and touch off on that. Okay. So I'm just barely kissing it there. So I'm going to dial in about 5 thousandths. And then we'll face that off and we'll take a measurement and see what we got. Okay, that's 201 and a half. So somebody got lucky here. I'm calling that good. And so I'll just smack a little chamfer on the OD and the ID, and we're going to call this quits here. Okay. And that gets put away. Alrighty. Alright, we're going to put this Woodruff key back in here. That's a little copper hammer. All right, well now we can get a check over on the machine, or on the drill press, and see what it looks like. If it looks good, then I'll reinsert this key up here, and actually I may clean this up a little bit just for fun. And anyway, that's fixed then.